Right, in this lesson we have a look at the applications of exponentials or the applications of logs. In your book it uses a equals something else in here. I can't remember exactly what it is. A equals, let me find my notes. A equals PR to the power of n. In different exams they use all sorts of different little formulas. I always stick with this one here. Okay, I think of it as fern, kind of sounds like, you know, a little fern. This looks more like a feather than a fern. I just feel like this acronym makes sense. So what it stands for is F stands for our final amount, I stands for our initial amount, R is your rate of change, and N is your number of either days, weeks, seconds, hours, whatever the time frame is. Okay, in terms of rates of change, this little diagram here from your Walker book is just fantastic. If there is no rate of change, then R is just equal to 1. If there is an increase, R is greater than 1. So an increase of 15%, R is 1.15, with the 1 being the one change and the 0.15 is the additional 15%. And then a decrease of 20% is R equals 0.8. So that's your one takeaway, your 0.2. To solve application questions, always read the information thoroughly. Okay, application basically means a word problem. You need to read through it thoroughly. You need to write an equation using Fern. Use knowledge from solving log problems to find the unknown, and it's likely you need to draw on other algebra skills also. Right, so for this example, I've just taken this straight from last year's NCEA exam. It was quite an interesting context because it's all about a virus, which is exactly the reason why we're doing distance learning right now. Right, so the number of people N suffering from a contagious virus increases exponentially at a constant rate of 5.3% each week after the virus was initially diagnosed. If N0 is the number of people initially diagnosed with the virus, then T weeks after the virus was initially diagnosed, N can be modeled by the function blah, blah, blah. Now, I just kind of tend to ignore these things here, okay, because I know I like Fern, so I don't worry too much about that. I do, however, draw out bits of information like this, okay, which is also up here as my rate of change. How long will it take for the number of people diagnosed with the virus to be 3 times the number initially diagnosed? So in this problem, we're looking for N in our little Fern equation. We haven't been given a final or an initial, but we can decide what those would be. So we could decide that our initial amount is going to be 1 person, okay, and then our final amount will be 3 people because we're looking for the virus to be 3 times the number of people initially diagnosed. We know that our rate of change is 1.053 and we want to find N. Okay, so in my Fern equation, I put 3 is 1 times 1.053 to the power of N. Divide both sides by 1 to get rid of this. 3 divided by 1 is still just 3. We get 1.053 N. All right, we're trying to find our exponent. So log of both sides. Then the N can come to the front using our log rules. Okay, divide both sides by the log 1.053. We get log 3 divided by log 1.053 equals N. And we finally get N equal to 21.27, 2 decimal places. Okay, so how long will it take for the number of people diagnosed with the virus to be 3 times the number initially diagnosed? Time it will take is 21.27 weeks. Okay, I know it's weeks because somewhere in here, 5.3% each week. Okay, so I knew that that was my time frame. That was a merit level question. That's how you solve that one. This question did have two parts. Here's part two now. So the number of people N suffering from a different virus also increases exponentially at a constant rate of R% each week. 2,500 people were initially diagnosed with the virus. After 10 weeks, the number of people suffering from this virus had increased to 4,250. Find R. Okay, assuming the form of the model, that's just telling you about the little equation. Like I said, I kind of ignore that because I like my own little equation fern. Right, going back to the information given to us, we've got a final amount here of 4,250. We have our initial amount of 2,500. Okay, rate of change, we don't know. And N was 10 weeks. So we can set up our equation. All right, to get R by itself over here, we need to divide both sides by 2,500. Okay, and we get 1.7 equals R to the power of 10. To find R, we need to take the 10th root of 1.7. Okay, do that to both sides to get rid of that to the power of 10. And then we get R is equal to 1.0545. That's to 4 decimal places. Okay, and our rate of change, remember, is the bit after the 1. Okay, so the rate of change the percentage of the rate of change is 5.45%. Okay, because if we multiply 0.0545 by 100, that's what we get. To practice these, you can go to Walker, pages 30 to 34, or jump onto Learn Coach and have a look at some past exam questions.